Hello again to all subscribers and listeners of this channel. Again, this is Why Evolution is Bullshit, Part 3. Human Evolution? Numbers 4 through 6. Evolution is the hypothesis, posing as a theory, that people believe as a fact. We are now moving on to numbers 4 through 6 of why Homo sapiens and all other large ape-type species have not been proven to have evolved from a common ape ancestor. So without further ado, let us continue. Number 4. Homo sapiens sapien doesn't just have a larger brain and a larger skull. It has a more complex brain and a differently shaped skull. It's not just simple as the brain got larger and bigger. There's so many other things that happen to the brain case and the brain activity of Homo sapiens sapiens that evolution cannot really explain very well. Let's break it down. 4A, what the apes have. The apes, such as gorillas, chimpanzees, and orangutans, have a more cone-shaped skull. They have some form of sagittal crest, as in a ridge or a line of extra bone that sits directly in the center of the skull that goes over it from the front of the skull to the back, which is most prominent in gorillas, but all three ape species have some form of this. And it acts as an attachment for very powerful and much larger jaw muscles. The apes have a lesser developed prefrontal cortex. The cerebellum is proportionally greater percentage of the ape's brain as compared to the human brain. 4B. Now let's look at what we have, human beings. What we humans have is not simply a larger brain. We have deeper, more complex gyri, and that are the little folds that are inside the actual brain. We have more advanced, more complex prefrontal cortex, and overall a more advanced cerebrum, which is proportionally much smaller cerebellum. But we as humans also have far more actual neurons in our brain compared to the great apes. And I can't remember the exact numbers, but I want to say among the three great apes, they have somewhere between 28 billion to about 40 billion neurons. Whereas human beings, once we reach full adult stage or whatever, we have an average of about 87 billion neurons. So the highest number of neurons that we have in the apes is less than half of what the average human being has. And there doesn't seem to be any theory as to how that would have happened. Nothing in the fossil record can show us how the brain will gain more neurons or how there will have been more neurons throughout the body. There's no way to show that transition. So, to simply say that the brain of a common ape ancestor supposedly grew and eventually became the human brain and also became the other brains of the other apes is severely oversimplified. The brains of the species aren't just bigger. They're more advanced, more complicated, and require more moving parts in order for them to work correctly. Something that, again, has not been explained very well in the evolutionary theory. 4C, what the skull had to have done over time. The skull of Homo sapiens sapiens not only had to grow to accommodate a larger brain, it most likely lost the sagittal crest, as well as became rounder. It may have also had to reposition itself to hold smaller jaws, become more circular, more spherical, and over time become more delicate, less robust, and go through all these morphological changes outside of just getting bigger. And again, evolution has no explanation for this, not just changing the brain case size, but changing its shape and the different features within it. 4D, the skull and the pelvis, like I said earlier, are essential to the survival of the more intelligent upright species. As explained back in Why Evolution is Bullshit Part 3, Human Evolution, and it's number 3 in that past video. The skull and the pelvis both had to remain within a very close range of each other in order to facilitate giving birth by the mother. They had to have been made nearly perfectly and had to stay in that range for many thousands of generations. Otherwise, the species could have gone extinct. So again, however we came into being, we already had the pelvis and the skull in a pretty tight range for us to give birth. There's no way they were smaller at some ancient time. That doesn't make any sense. But again, I explained that in the earlier part of the series. So go back to the previous video before this one. And this all occurred simply because of an increased intake of protein. As I've said before, I'm not sure protein over many generations could drastically change the position, size, characteristics, and shape of both the skull and the pelvis of Homo sapiens, and then keep them growing and changing at exactly the same rate for multiple generations. I mean, we're talking about thousands, maybe even tens of thousands of generations where this had to occur consistently without too much of a problem. Doesn't make sense. 4E. It's as bad as saying chimpanzees have slightly larger skulls and more refined bodies than orangutans. So therefore, orangutans are older and predate chimpanzees by a few 100,000 years. No. They obviously coexist right now. They exist at the same time. Number 5. Apes did not collectively drop down from the trees and become terrestrial. That doesn't make sense, and here's why. 5A. The hominids, what we call the ancient hominids, the 25 or so hominids that we found in the fossil record so far, they're not built to be arboreal. Their arms and back muscles seem too weak to climb up a tree, as well as their legs being too long and having too much surface area. So did they even live in trees at all at some earlier time? I highly doubt it. Their proportions and their physiology is way too similar to us humans. Their legs seem too slow to really run. Like they could run, but they probably couldn't run fast. Just like human beings can't really run fast like that. And according to the evolutionary theory, they develop walking to evade predators, which doesn't make sense. The problem with that is that even the fastest human today, Usain Bolt, cannot outrun most major predators. And I'm going to put a link in the description. I'm going to put some graphics up so you can see what I'm talking about. Usain Bolt's sprint is somewhere between about 27 to 30 miles per hour. Lions clock in at about 45 miles per hour. Hyenas can go up to about 55 miles per hour. Cheetahs are somewhere between 65 to 75 miles per hour. Wild painted dogs clock in about 50 to 60 miles per hour. These predators can still outrun today's humans, let alone Homo erectus. Someone explained how Homo erectus getting to the ground and walking would have been used to evade predators. It's like, let me break this down so that way you understand the flaws in this evolutionary logic. So, how did the Homo erectus evade predators when it weighed barely 100 pounds, stood about maybe 4.5 to 5 feet tall, and even more so, why would it leave the trees to become terrestrial if it barely knew how to walk somehow, let alone run from danger? They're small, they're svelte compared to chimpanzees, they're lighter, they're slimmer, they're weaker, and proportionally they should be slower. They should be slower even than today's humans. They can't run as fast. But they chose to live on the ground and left the trees, despite the fact the trees were their safest haven away from almost all predators. What? 5B. If they actually did live in the trees at some point and then went to the ground, doing so would have been suicidal. Most predators back then and today cannot climb trees. And the predators that could climb trees would still be much heavier and much bigger than Homo erectus and all the other hominids, so they wouldn't have been able to get up to the tree as high. Yet we're supposed to believe that the ape willingly left the safety of the trees to be among less food, as in there's less food on the ground compared to some of the food that's in the trees, if you look at certain ecosystems. And if there was food on the ground, they would have had to travel much further away to get the food, and it would have taken them longer to gather it. So they're now in a more open area where there's less cover and less protection from predation. The tree's height and increasingly small limbs would have been the best protection against predation. On the ground, there's only grass to cover you, but nothing to actually protect you. And somewhere in this video, you're going to see a graphic that shows 4 different type of advanced hominid type beings, or whatever you want to call them. And you'll see the 4 different types of locomotion. You're going to see brachiation, quadrupedal walking on, or like arboreal quadrupedalism, terrestrial quadrupedalism, and terrestrial bipedalism. Those 4 ways of moving just don't seem to connect with each other at all. But again, evolution wants us to believe that they all have a common ancestor, with no actual proof of that. But let me go on. Now, on the ground where you're terrestrial, you have the larger, more vicious predators. And again, most predators such as crocodiles, hyenas, wild dogs, cheetahs, etc. cannot climb trees. The predators that can climb trees, lions, leopards, etc., they can't climb as high because of their heavy weight. So these early hominids, because they're so heavy, had a better chance of getting away from these predators, even the ones that could climb. But evolutionists want us to believe that early hominids somehow left the trees, which was their safest haven away from predators, and went to the ground to evolve upright walking, which would not have aided them very well in terms of surviving predation, since most of the predators could still outrun them. Someone needs to explain the flaw in that logic. That doesn't make any sense. Something's not right somewhere. 5C. Homo erectus did not start in the trees. I'm pretty sure, however they came into being, they already were walking from day one. They were built to walk. They always walked. They were always bipedal. And then go on to the ground bipedally. So they started in the trees, then went to the ground bipedally. Not buying it. If Homo erectus operated the way we assume it did, looking at a skeleton, Homo erectus most likely had a huge population with a high fertility rate. And that's what I think they used to protect themselves against predation. They just had a high fertility rate, and that's what kept them alive as a species for a long time. Because a Homo erectus, when you really compare it to all the other prey animals, was probably the easiest thing to kill. They had no fangs, no claws, may have been weaker and slower than chimpanzees and humans, but were on the ground out in the open, surrounded by predators that could easily outrun them, tackle them down, and kill them. So the only thing that makes sense to me is that they had a high fertility rate maybe, and a strong social cohesion that probably created situations where Homo erectus were hunted in their, I guess, more herd or large groups, and the ones that were hunted and killed were simply replaced by the high fertility rate. That's the only thing that would have kept the species alive as a whole in large numbers. When one considers that what the pelvis has to do in order for an organism to walk, climb, swim, etc., the pelvis of Lucy and other Homo erectus was already built for walking and was probably never used as a primary body part for climbing. Again, as stated before, where are the transitionals? Again, when you see that part in the video with the 4 different organisms and the way they move, the bipedalism on the ground, the quadrupedalism on the ground, the brachiating, and the quadrupedalism in the trees, you're going to see there's not enough evidence that they have a common ancestor. There's not enough evidence that there's a transitional that became those 4 different things. We don't see it in the fossil record. We don't see even a fraction of the number of species that should be there in the fossil record. So as far as I can see, all this talk about evolving bipedalism is hypothesizing. Very bad hypothesizing. Number 6. The great apes are built like pendulums. The hominids are built more like humans. When I say hominid, I'm talking about like as Homo erectus, Neanderthals, Heidelbergensis, they're not built like apes. They're built way more like humans. And there doesn't seem to be an in-between. There's not enough evidence of the actual transitional. Either you are terrestrial and you walked on the land, or you are arboreal and you lived in the trees. There doesn't seem to be enough evidence of an in-between. 6a. If one looks at the great apes, both alive and extinct, one notices fairly quickly that they have similar characteristics, such as the long arms, the large abdomens, the shorter legs, etc. Why? Because they need the proportions to brachiate. What is brachiation or brachiating? Brachiating is the ability to swing through the trees using only your arms. To do this, you need to be immensely strong, have relatively long arms, a well-developed upper trapezius or an upper latissimus dorsi muscle, and have a rounder lower body that stays centered while brachiating. You're swinging from branch to branch like a pendulum. Homo sapiens and other hominids do not have this body structure. We are not built anywhere near like this. And neither were the Neanderthals, Heidelbergensis, Homo erectus. None of them have the brachiating body structure of, say, a gibbon or a chimpanzee. Our upper body strength is way too low. Our legs are way too long. And our legs are too heavy. We have a much slimmer torso and arms that aren't long enough to hook onto tree branches in that manner. In other words, human beings, by and large, can't really brachiate. We kind of can do it, a little bit of it, like in that parkour stuff. But that's not the true brachiating of what you'll see in a gibbon video or what chimpanzees do. And if we did try to brachiate the way chimpanzees do over a long period of time, or brachiate like a gibbon would do, because I'm going to link to a video in the description where you're going to see a gibbon do the true brachiating on a monkey bar thing, you're going to see that's the actual brachiating. Human beings, I highly doubt we could actually do that. If we tried that actual brachiating, you're going to see in that video, linked in the description, we would dislocate our shoulders, tear skin from our hands, pull our latissimus dorsi and our trapezius, so it's really sore and severely damaged. We're going to overexhaust our abdominals and eventually fall to the ground, and or eventually fall to our eventual death, depending on how high we're falling from. 6b. Where the great apes both live and the extinct apes live so the great apes, both the ones that are alive and the ones that are extinct, they both have what appear to be pot bellies, the longer arms, the shorter legs, with the greater overall upper body strength, etc. So when one looks at a chimpanzee or a younger gorilla climbing, you'll notice their body has an actual pendulum shape. It's shaped kind of like a pendulum. It's long up top and round and short on the bottom. Greater strength with a rounder body and lower center of gravity is perfect for brachiating. Oh, and before anyone talks about human brachiation, again, you're going to see the videos linked in the description, and you're going to see the difference between so-called brachiating, what we humans can kind of do, versus the actual brachiating of a gorilla or orangutan or a gibbon or a chimpanzee. So let me break it down. B1. First, a lot of that you're going to see in the video in the description, what they call brachiating, is jumping around and it's using a lot of momentum. So jumping and momentum are mixed in. They're not using exclusively their arms. B2. The people who do this have practiced it for years. So it's not innate for us human beings to move like that. B3. The place they're brachiating in was constructed. B4. They're not doing the brachiation like chimps and gorillas. That's going to be obvious when you compare the human brachiation to the ape brachiation when you watch both videos. Again, linked in the description. So click the link in the description and you'll see what I'm talking about. B5. Now let me explain the ape brachiation very closely. Great ape and monkey brachiation is one hand at a time, continuous movement, barehanded, no feet, through different sized tree branches of different lengths, different angles, and different distances from each other. That true brachiation is not something most human beings could ever achieve. Not even close. Even the parkour guys cannot do what that gimp is going to do when you watch the linked video. No. Now again, someone tell me, where are the transitionals? When we look closely at the anatomy and what it's supposed to do, our ape hominid cousins, either they walked or they climbed. They climbed or they walked. And there doesn't seem to be enough evidence of any hominid type being capable of doing both, as an evolutionary theory would have us believe. I'm going to stop right there. Well, that's all for now. Please like, subscribe, share, and donate to support this channel. You all have a nice day. I'm out. Peace.